Welcome back. In the previous lesson, we looked at system software, how operating systems, firmware, utilities, and application software work together to allow the user to do whatever they want to do. However, when you are writing computer programs, you need to make use of specific software that allows you to write, edit, test, and run those programs. And these programming languages that you use to write computer programs can be categorized as high level and low level. You should be able to explain what is meant by a high level language and a low level language, including the various advantages and disadvantages of each. You should also understand that assembly language is a form of low level language that uses mnemonics, and that an assembler is needed to translate an assembly language program into machine code. Programs are our way of telling a computer what to do, how to do it, and when to do it. This enables a single computer to perform many different types of tasks. A computer can be used to stream videos, write reports, provide weather forecasts, and many other tasks that it normally does. So what is a computer program? Well, it's a list of instructions that enable a computer to perform a specific task. And these can be written in high and low level languages depending on the task and the hardware being used. Most programmers write programs in high-level languages like Python. A high-level language uses human language style words, and these enable a programmer to focus on the problem to be solved and require no knowledge of the hardware itself. These type of languages are designed with the programmers in mind, and programming statements are easier to understand than those written in a low-level language. What all of this means is that programs written in high-level language are easier to read and understand. Humans can write these in a shorter time. It's possible to debug these at the development stage to reduce errors because you understand the statements. And it's easier to maintain these programs once they're in use. A program that is written in a high level language is considered portable, which means you can write a program on one computer and then run it on a different computer. Now, the following snippet of a program to add two numbers together is a single program statement written in a typical high-level language. It shows how easy it is to understand what's happening in a high-level language program. So the statement is sum equals first number plus second number. Now, there are many different high-level programming languages in use today, including C++, Delphi, Java, Pascal, Python, Visual Basic, and many more. The good thing is, once a programmer has learned the techniques of programming in any high-level language, these can be transferred to working in other high-level languages pretty easily. A loop at the end of the day is going to be a loop. A selection is going to be a selection. So you could apply that and just learn the new syntax or the command words of a high-level language, and you will be able to code in that language. Low-level languages, on the other hand, relate to specific architecture and hardware of a particular type of computer. They can refer to machine code, which is the binary instructions that a computer understands, or use an assembly language that needs to be translated into machine code. So there are two types of low-level languages, machine code and assembly language. So the computer will execute machine code pretty much straight away, and different computers may have different machine codes depending on the manufacturer. Machine code is often non-portable. That means you can't transfer a program written for one computer to another computer. Assembly language is an in-between stage. It uses mnemonics, which are basically shortened words to represent code. For example, to store data, we won't write store, we just use the mnemonic form, which is STO, store. Each high-level language statement is converted into assembly language instructions, which are then converted into machine code. Now, fewer and fewer programmers write programs in assembly language as it's often too difficult, but they do it for various different reasons, and some of those reasons are listed on screen. They do so when they want to make use of special hardware or when they want to make use of special machine-dependent instructions. They might want to write code that doesn't take up too much space in the main memory, so they will need specific addressing instructions. Therefore, it's better to use assembly language for that. And sometimes they might want to write code that performs a task very quickly instead of being translated from a high level to an assembly language and then to machine code. Now, on screen is an example of an assembly language program. LDA first, add second, store, sum. In order to understand the program, the programmer needs to know that LDA means load the value of the variable into the accumulator. Add means add the value of another variable to the value stored in the accumulator. And store means replace the value of the variable by the value stored in the accumulator. So you're saving the results somewhere. Now, this is the same thing as our high-level program, which did everything in one statement. Sum is equal to first number plus second number. But we need multiple instructions for low-level languages. Each low-level language line takes one processor cycle to execute, whereas a high-level language line might take multiple processor cycles to execute. But assembly language also needs to be translated into machine code. So why don't we write in machine code in the first place? Well, we don't do that because it's quite difficult to understand and it can be complicated to manage data manipulation and storage. Now, the following snippet of a program to add two numbers together is written in typical machine code, showing both hexadecimal and binary versions of those three statements. 1, 12, 4, 13, 0, 1, 8, that's hexadecimal. Otherwise, it's 0001, 0100, 0000, and then the equivalent instruction. So it's basically hex converted into binary there. This is not easy to understand at all in binary. That's why sometimes machine code is shown in hexadecimal. And even though it's a bit better, it isn't very easy either. That's one of the reasons why we use assembly language instead. Okay, on screen is a comparison table between high-level languages and low-level languages. High-level languages, one line of code can do several things. In a low-level language, one line of code does one thing only. High-level language needs to be translated by a compiler or an interpreter. We're going to be looking at those. Low-level languages need to be translated by something called an assembler. High-level languages are much more easier for humans to understand because they're closer to natural language. Low-level languages are equally difficult for humans to understand, but can be easily executed by a computer. High-level languages are portable. Low-level languages are not portable, but machine-dependent, so only run on the machine that they're coded for. High-level languages are easy to debug, and it's easier to find mistakes. Low-level languages are harder to debug by humans. High-level languages, therefore, can't manipulate hardware directly, whereas low-level languages can directly manipulate hardware. For example, you can write to specific memory locations, and that means programs are more efficient. Hopefully, you understand the differences between high-level and low-level languages. Some advantages: one is portable, easier to understand by humans; the other isn't portable, isn't easier to understand by humans, however, and lead to efficient programs, smaller source codes, and you can control hardware directly, whereas the other ones can't. You should be able to answer the following questions. You should be able to describe what is meant by a high-level language, and similarly, what is meant by a low-level language. You should be able to give at least two advantages and one disadvantage of a high-level language, and similarly, two advantages and at least one disadvantage of a low-level language. You should also be able to answer questions like this. Joe wants to write a program that uses very little memory. What type of programming language should he use and why? And then you should also be able to compare the use of a high-level language to a low-level languages for a new programmer. That's all for this particular lesson. If you do have any questions, please do let me know. Otherwise, I'll see you in the next one.